Hello friends, today we are going to learn regarding precipitation, and our today's learning objectives are hydrology and hydrologic cycle and rainfall measurement. Actually in the last lecture we have seen the hydrology and hydrologic cycle, but the precipitation we are going to study in detail, and which is a part of a hydrology. Hydrology and hydrology cycle, or it is called as a hydrologic cycle. Precipitation includes rain, snow and other forms of water falling from the atmosphere into the land and oceans. Evaporation, physical process by which water is vaporized into the atmosphere from free water surface and land areas. Transpiration, water from the soil is absorbed by the plant roots and eventually discharged into the atmosphere through little pores and in the leaves called stomata. Evapotranspiration, combined processes by which water is transferred to the atmosphere from open water surfaces and vegetation. Infiltration, movement of water from the land surface to the upper layers of the soil. Percolation, movement of water through the subsurface down to the water table. Overland flow, portion of runoff that travels over the surface of the ground to reach the stream channel. Surface runoff, it includes all overland flow as well as precipitation falling directly onto stream channels. Today we are going to study in detail regarding the precipitation. Forms of precipitations are drizzle, a light steady rain in fine drops 0.5 mm or less than that, and intensity less than 1 mm per hour. Rain, the condensed water vapor of the atmosphere falling in drops greater than 0.5 mm, maximum size 6 mm from the clouds. Glaze, freezing of drizzle or rain when they come in contact with cold objects. Sleet, frozen raindrops while falling through air at sub-freezing temperature. Snow, ice crystals resulting from sublimation, that is water vapor condenses to ice. Hail, small lumps of ice greater than 5 mm in diameter formed by alternate freezing and melting when they are carried up and down in highly turbulent air currents. Dew, moisture condensed from the atmosphere in small drops upon cool surfaces. Frost, a feathery deposit of ice formed on the ground or on the surface of exposed objects by dew. Fog, a thin cloud of varying size formed at the surface of the earth by condensation of atmospheric vapor. Mist, a very thin fog is called mist. Now let's see the types of precipitation. First one, convectional precipitation. It results from heating of the earth's surface. Due to this, the warm air rises rapidly into the atmosphere. As the air rises, it cools. Water vapor in the air condenses into the clouds and precipitation. The orographic precipitation. It results when warm, moist air moving across the ocean is forced to rise by large mountains. As the air rises, it cools. As the air cools, the water vapor in the air condenses and the water droplets form. Precipitation occurs on the windward side of the mountain. The air is now dry and rises over top of the mountain. As the air moves back down the mountain, it collects moisture from the ground via evaporation. Next is cyclonic precipitation, or it is called as a frontal precipitation. Cyclonic precipitation is caused by lifting of air mass due to the pressure difference cyclonic precipitation may be either frontal or non-frontal cyclonic precipitation. Generally, when the warm air rises over the cold air, then it is called as a frontal, and in case of the cyclone itself, it is a non-frontal. You can see the figures here. Convectional precipitation, the moist air is you can see rise here because of the hot surfaces in between, and it is cooled by the cooled here air because of the condensation, and the precipitation takes place. Okay, this is called as a conventional precipitation. Then you can see the warm moist wind, it rises over the mountain. Okay, here because of the cooling, it get condensed precipitation take place, and the dry air moves down, and again it collects the moisture from this area. Then frontal precipitation, you can see this is a cold front is there. Okay, this is warm front which rises on the cold front, and this precipitation takes place. Okay, this is a frontal one, but in non-frontal, or you can say cyclonic precipitation, a cyclonic action, or you can say the rotation is there. So you can understand that cyclonic it is a due to the rotation of the air masses. Now you can see next we will move to the storm or heavy rain characteristics. The characteristics of a storm, namely depth, duration, intensity, and distribution, affect the watershed response to the rainfall event. Depth, amount of precipitation that falls, usually in inches or centimeter. Duration, length of a storm, usually in minutes, hours, or day. Intensity, depth of rainfall per unit time, usually in inches per hour or centimeter per hour. Rainfall intensity changes continuously throughout a storm, but it may be averaged over short time intervals or over the entire storm duration. Distribution, describe how rainfall depth or intensity varies in space over an area or watershed. A measurement of rainfall and optimum number of rain gauges. The basic instrument for rainfall measurement is rain gauge, which samples the incidence of rainfall at a specific point through an orifice of known area. Generally, we are calling it as a rain gauge station. Types of rain gauges. First one is the non-recording rain gauge. The non-recording rain gauge used in India is Simon's rain gauge. The rainfall is measured every day at 8:30 hours IST. During heavy rains, it must be measured 3 or 4 times in a day, lest the receiver fill and overflow. But the last measurement should be at 8:30 hours IST. Second, recording type rain gauge. In that 3 types are there: tipping bucket rain gauge, weighing type rain gauge, floating type rain gauge. These type of gauges are used by Indian Meteorological Department, IMD. First one is we'll see the non-recording gauges or rain gauges. The non-recording gauges extensively used in India is the Simon's gauge. It essentially consists of a circular collecting area of 12.7 centimeter 5 inches in diameter, connected to a funnel. The rim of the collector is set in a horizontal plane at a height of 30.5 centimeter above the ground level. The funnel discharges the rainfall catch into the receiving vessel. The funnel and receiving vessel are housed in a metallic container. You can see the cross section of this rain gauge. Generally, this particular metal container is fixed in a concrete body, but sometimes stand type container is also available. You can see a funnel is there, which is being immersed into a collecting bottle, and these are the standard you can say dimensions that you have to remember. Okay, and at present you can see this is mounted on a concrete block. You can see a pictorial view of a non-recording type of Simon's rain gauge. Okay, it should be situated away from any obstruction in a free area. Now you can see that it is fixed on a stand here on a concrete block. Okay, and inside that the funnel is provided here. At this particular part, a bottle is there. Next one is a tipping bucket type rain gauge. This is a 30.5 centimeter size rain gauge adopted for use by the US Weather Bureau. The catch from the funnel falls onto one of a pair of small buckets. These buckets are so balanced that when 0.25 mm of rainfall collects in one bucket, it tips and brings the other one in position. The water from the tipped bucket is collected in a storage can. The tipping actuates an electrically driven pen to trace a record on the clockwork driven chart. The water is collected in the storage can is measured at regular intervals to provide the total rainfall and also serve as a check. It may be noted that the record from the tipping bucket gives the data on the intensity of rainfall. Further, the instrument is ideally suited for digitalizing of output signal. You can see this tipping bucket is being provided to a recording device. This is a tipping bucket which collects the water and tips down, and which water is collected in a measuring device here. Okay, you can see here the diameter is 30 centimeter. This is the receiver. This is a funnel. Okay, this is, you can see this is a pictorial view of that. This is a tipping bucket is there. Okay, so inside this funnel is there, which this particular part is kept on this. Okay, and when the water falls on one of the bucket, that becomes empty and collects water here. Okay, and the recording is taken from this electrically, or you can say the electronic device. Weighing bucket type rain gauge. In this rain gauge, the catch from the funnel empties into a bucket mounted on a weighing scale. The weight of the bucket and its contents are recorded on a clockwork driven chart. The clockwork mechanism has capacity to run for as long as 1 week. This instrument gives a plot of the accumulated rainfall against the elapsed time, that is the mass curve of rainfall. In some instrument of this type, the recording unit is so constructed that the pen reverses its direction at every preset value, say 7.5 centimeter, 3 inches, so that continuous plot of storm is obtained. You can see the cross section of this weighing type rain gauge. You can observe the funnel, the collecting area is there. This is a catch bucket which is mounted on a spring balance. The water get collected. Okay, and this is the revolving drum is provided, and with the supply the clock mechanism is provided, so it keep on rotating. Pen is there provided, and which continuously records on this chart which is mounted on this, and a continuous record can be maintained. This is the pictorial view of that, you can see. Okay, so this is a chart which is provided. You can observe the record of this, and this is the tip, or you can say pen is provided there. Okay, and it is supplied with the some electrical energy, so that clock mechanism should work. Next one is a float type gauge or natural siphon type rain gauge. This type of recording rain gauge is also called as a float type gauge. Hence, the rainfall is collected by a funnel shaped collector is led into the float chamber, causing a float to rise. As the float rises, a pen attached to the float through the lever system records the elevation of the float on a rotating drum driven by the clockwork mechanism. A siphon arrangement empties the float chamber when the float has reached a preset maximum level. This type of rain gauge is adopted as the standard recording type rain gauge in India, and its details are described in Indian Standard IS 5235 1969. Thereafter the amendment is also there. You can see the cross section of this. You can observe the funnel. This is the collecting area of this. Okay, then it collect. This is the filter provided there to take the clear water there, right? It collects the water in this particular float chamber. A float is provided here. This is a siphon arrangement to empty this particular float chamber. Here the clock mechanism is there. This is a chart is mounted, pen is provided here. So floating of this will be recorded on this particular chart. Okay, so this is called a revolving drum, and a pen is provided there. And again this will require the supply to operate this particular system. So you can see the pictorial view here. This particular part is kept on this particular part. This is the bottom part, and this is the upper cylinder. You can see it is kept on this, and the arrangement which is we are discussing is the ink is there. Okay, you can see the pen and this clock mechanism. Okay, so we can see the recording of here on this chart. Okay, this is a typical chart from this type of rain gauge which is shown in this figure. This chart shows rainfall of 53.8 in 30 hours. The vertical lines in the pen trace correspond to sudden emptying of the float chamber by siphon action, which resets the pen to zero level. It is obvious that the natural siphon type recording rain gauge gives a plot of mass curve of the rainfall. You can see here in the 30 hours it is 53.8 mm. Now this is the chart area, you can see. So how many drops are there? 1, 2, 3, 4, 5 drops are there. So that comes to the 50. Then again you can see the how many divisions have been crossed. 1, 2, 3. That goes to the 53, and again this will be subdivided here. So it is 8 parts are there. 53.8 in 30 hours. In 30 hours, the hours are mentioned is 24. Okay, and this is recorded for the 30 hours. Okay, so it is very easy to understand as well. The next one is a telemetering rain gauge. These rain gauges are of the recording type and contain electronic units to transmit the data on rainfall to a base station both at regular intervals and on interrogation. The tipping bucket type rain gauge, being ideally suited, is usually adopted for this purpose. Any of the other types of recording rain gauges can also be used equally effectively. Telemetering rain gauges are of utmost use in gathering rainfall data from mountainous and generally inaccessible places. So you can see the view of this telemetering rain gauge. So this is the collecting area again here, and these electronic units are used which transmit the data of rainfall to the base station, which is that electronic data will be collected. Now next one is a radar measurement of rainfall. The meteorological radar is powerful instrument for measuring the aerial extent, location and movement of rainstorms. Further, the amounts of rainfall over large areas can be determined through the radar with a good degree of accuracy. The radar emits a regular succession of pulses of electromagnetic radiation in a narrow beam. So you can observe a radar is there, okay, which this is the frequency of the waves, okay, transmitted pulse of electromagnetic waves are there. So the clouds are there and precipitation. So this obstruction, okay, these are the returning echoes are there, which is received, and the intensity, then position of this particular location, you can see it is given by this radar measurement. Nowadays these are in more use. Now optimum number of rain gauges. How many rain gauges should be provided? There is one formula. Statistics has been used to determining the optimum number of rain gauges required to be installed in a given catchment. The basis behind such statistical calculation is that a certain number of rain gauge stations are necessary to give average rainfall with certain percentage of error. If the allowable error is more, the lesser number of gauges would be required. The optimum number of rain gauges n can be obtained using, you can see the formula, n is equal to CV, V suffix, divided by E and bracket square, where CV is the coefficient of variation of rainfall based on the existing rain gauge stations, that is equal to mean divided by standard deviation of rainfall. Capital E is equal to allowable percentage error in the estimate of basic mean rainfall. So we are going to study again in details how to calculate the number of rain gauges. So it is because that we should get the accurate data, and if any rain gauge is not working, the rain gauge in the vicinity, that can be used for the analysis purpose. So today we'll stop here with the measurement of this rain gauge or rainfall, but in next lecture again we are going to see how the analysis is to be carried out of all this measurement, and very interesting thing that the precipitation and its measurement and also the analysis. So there are various methods are there. Those methods are very interesting. Thank you very much for joining this session, and tune up with all the lectures. Thanks once again.